In this video, let us solve more problems based on trigonometric ratios of complementary angles. So here we've got a question. Prove that sine 35 degrees into sine 55 degrees minus cosine of 35 degrees into cosine of 55 degrees equal to 0. We need to prove that this expression equals 0. So what we can do here is, now either the best way to prove that this expression equals 0 is either change this to cos or change this to sine, right? So let's try changing this to cos. So we can write sine 35 degrees as sine of 90 degrees minus 55 degrees, because 90 minus 55 is 35. And sine of 55 degrees is 90 minus 35 degrees. Right, minus, let's keep this as it is, cos 35 degrees multiplied by cos 55 degrees. Let's keep it as it is. So sine of 90 minus theta is cos theta, right? So sine of 90 minus 55 is cos 55 degrees. And sine of 90 minus theta again is cos theta. So sine of 90 minus 35 is cos 35 degrees. So cos 55 minus cos 35 minus cos 35 cos 55 is the same as, both of them are same. It doesn't matter if there is A into B is same as B into A, right? So in that case, this cos 55 degrees cos 55 degrees into cos 35 degrees minus cos 35 degrees cos 55 degrees equals 0. So that's all. This is a pretty simple sum. The point here is to convert either sine or cos into one of them. You can also convert cos into sine. You can write cos 35 as cos 90 minus 55 and cos 55 is cos of 90 minus 35, and then that becomes sine 55 and sine 35, and again you get a 0. There are more than one ways to solve this problem. Alright, let's quickly solve another problem. So we've got another problem here which reads like this. Prove that cos 70 degrees by or over sine 20 degrees plus cos 59 degrees over sine 31 degrees minus 8 sine square 30 degrees equals 0. So how do we go about solving this problem? It seems pretty simple, because you can see that cos 70 degrees can be written as cos of 90 minus 20 degrees, and in the denominator we've got a sine 20, so it's kind of an indicator. And plus again cos 59 can be written as cos of 90 degrees minus 31. It's pretty easy to guess 90 minus what gives you 59, because you just have to see the denominator, because the problem is going to be in such a way that you're going to get results, right? So, and also, I mean, 90 minus 31 is going to give you 59 degrees. So, yeah, sine 31 degrees and minus 8 sine square 30 degrees. Now, this is a standard angle, right? One of the standard angles. And the value of sine 30 is 1 by 2. So, 8 multiplied by 1 by 2. And it's not only sine 30, it's sine squared 30. It's 1 by 2 the whole square. So cos of 90 minus theta is sine theta, and cos of 90 minus 20 is sine 20 degrees. So sine 20 degrees by sine 20 degrees plus again cos of 90 minus 31 is sine of 31 degrees divided by sine of 31 degrees minus 8 into 1 by 2 the whole square is 1 by 4. So 4 goes 2 times in 8. Sine 20 gets cancelled for ones. So, for 1. So 1 plus 1 minus 2. So 2 minus 2 equals 0. So hence proved. So we proved that this expression equals to 0 using the relationships of the trigonometric functions of complementary angles. So once you're familiar with the relationships, then it's pretty simple to solve these problems. So let us solve more problems in the forthcoming videos.